If you're interested in data science, you're going to need to learn Python. Python has become a cornerstone of data science, offering a rich ecosystem of libraries and tools that streamline data analysis, machine learning, and data visualization. Its readability, flexibility, and extensive community support make it an ideal choice for both beginners and experienced data scientists. That is a quote from Gemini in 2024, a large language model created using machine learning. So what is data science? Data science is an umbrella term that incorporates a lot of different technologies and skill sets. One way you can look at data science, looking at this image, you see three different areas. The blue area is computer science, red is statistics and math, and green is business and domain knowledge. At the intersection of these pillars lies data science. If we take, say, 2 out of 3 and think about what types of activities happen in that space, if you look at computer science combined with statistics and math, you might see statistical programming in that space, where somebody with a background knowledge in statistics and a background knowledge in computer science and programming can actually program some statistical-based applications, so applications for doing statistics. If you combine computer science with business and domain knowledge, you get traditional data and software engineering. So in order to engineer software, a computer scientist needs to know, first of all, how to create the software, but also have some business and domain knowledge, needs to learn about the business that the software is being created for, or the domain in which the software is going to be deployed in order to engineer that piece of software. And the same is true if you're doing data engineering. We live in a data-driven world, so data engineering is a field that is quite popular, and it's combining computer science, again, with some business or domain knowledge. If we combine statistics and math with the business and domain knowledge, then we get research and analytics. So individuals who are doing research and performing data analytics are going to have some statistical background in addition to knowledge in the domain or business with which they are conducting their research and analytics. And of course, all of these combined fall under the overall data science umbrella. And if you ask different individuals and even people in different companies what data science means, you might get a lot of different answers. But generally, there is a large umbrella of areas that are covered by the general term data science. And when you're looking for careers or thinking about what it is you want to do, you should really be more specific about specifically what you want to do within the domain of data science, and ensure that you're looking at the right techniques and technologies that you need to learn. In general, under data science, we use Python. The fundamentals of Python are going to be required across all of these domains. And that includes the basics of the language, which are syntax and data structures, the control flow of the language, so the control flow statements, and the functions and modules that can be built and used with the programming language. So Python fundamentals are a great place to start with data science in Python. I have a link here to the documentation, and this is the official Python documentation. When you learn Python, and even as you continue learning Python throughout your career, you will always come back to the documentation. For beginners, you might want to start with a tutorial. So a Start Here tutorial. The Python tutorial is a good place to start. And then you can move on to the language reference that tells you about the syntax of the language and the elements of the language. And then the library reference which is the details of across the entire Python library. This is a reference that you will continually go back to, so this is something to bookmark. And this tells you about all of the main components of the language. After you've already learned the basics, you can go through these and get the details on all of the components, what functions are built in, what are the built-in constants, the data types. There are exceptions, text processing services, which are quite commonly used, binary data services, different types of data, more advanced types, numerical methods and modules, functional programming modules, modules for performing file I/O, so file input and output, persisting data, translating data, formatting data, moving data around, and so on. So the Python docs, if you're learning Python or even currently using Python, the docs are somewhere that you will go frequently. Here you will also find links to other tutorials under Tanya AI that will have their own associated videos. For example, Python Basics and Control Flow in Python. In addition to the fundamentals after learning Python, if you're going into a data science career, you need to know NumPy and Pandas. NumPy and Pandas are primary libraries for manipulating and working with data. There's a link to NumPy here. NumPy provides us some powerful n-dimensional arrays that are fast and versatile that allow us to do array-based mathematics and manipulation in a very efficient way. In the documentation for NumPy here, you can use the interactive shell to try out NumPy. And you'll see over on the left some Python code that you can try. The first thing we see is an import statement, which imports NumPy, something we'll learn in another tutorial, how to import different libraries into your script. And if you just want to play with NumPy here, you can write your own code, or you can copy and paste some of the code that's provided for you here and execute it. For example, this is creating a NumPy array using a range of 0 to 15 and then reshaping it to 3 rows and 5 columns. We want to see what that looks like. This is an example of what a n-dimensional NumPy array looks like. So this is a data structure format in NumPy. And then, of course, NumPy provides you with a lot of functions that you can use to get more information. For example, if we take our array here, maybe we want to know what is the max value in each of these different rows. And we can use the NumPy function max, which will return the maximum value in each row in a new NumPy array. So we see 4, 9, and 14. So NumPy is a library that you will absolutely want to get familiar with and learn how to use. And then Pandas. Pandas provides us with data frames and series. And Pandas and NumPy are very tightly linked together. Pandas is using NumPy data structures underneath. And you can go to the Pandas documentation. If you're new to Pandas, start with the Getting Started guide for installing Pandas to work with Python. Go to the user guide to get more information on step-by-step all of the components of Pandas, how to use Pandas, working with Pandas data frames. And then the API reference. So again, after going through all the introductory material and learning Pandas, you'll come back to the API reference throughout your time of using Pandas to go back and see what the different methods and functions are for performing tasks that you want to perform. The functions across data frames, the functions across series, inputs and outputs. And if you're wondering what data frame is, A data frame looks like a table. So if we look at the data frame structure, we end up with something that looks like, let's go back to the Getting Started guide and see if we can find a good picture here. Let's go straight to one of these tutorials. Here we go. Here's a data frame in Pandas, and a data frame looks like a table that you would see in a spreadsheet. It has rows and columns, and those can have headers, header row and a header column. And that's the general structure of what a data frame looks like. And so you can operate on a data frame across its rows and columns. That is what Panda provides in terms of working with data in the field of data science. See if I can work my way back to our document here. So in addition to learning NumPy and Pandas, you want to learn data manipulation and cleaning in general. So when data comes into a process in data science, it typically needs to be cleaned in some way, doing some pre-processing on the data to get it prepared for your analysis or machine learning, if that's what you're doing. And you need to know how to manipulate and work with the data. In addition to data manipulation, there is data visualization. You want to be able to present visualizations that give us information from that data that are easier for humans to look at and understand. Some of the data visualization libraries include Matplotlib, this is visualization with Python. You see here a histogram. There is different plot types that you can create, and you can see the examples of the plot types here in the documentation. For example, if you have pairwise data, you can plot scatter plots, bar plots, line plots, stack plots. You can plot statistical distributions and data grids. And you can also create three-dimensional data plots with Matplotlib. And here at the documentation, we have, again, a user's guide. So there's a quick start guide if you're new to Matplotlib, tutorials that you can walk through step by step, working with plots and images. Incidentally, PyPlot actually goes very well with Pandas as well. So Matplotlib, Pandas has a visualization component that is Matplotlib under the hood, known as PyPlot. So those are, again, very closely related. So you'll hear about NumPy, Pandas, and Matplotlib together frequently, as those Python libraries are used tightly in conjunction and very common across data science. Another visualization library that's quite popular is Seaborn. And Seaborn also allows you to do statistical data visualization, again, plotting different values in different ways. Here they have a gallery where you can look through a gallery of plots, determine a plot that will best visualize the story that you're trying to tell with your data. And you can then click on that plot and get an example of Python code of how to create the plot that you could then copy and use as a starting point on your data. So you can see the utility of both of these visualization libraries. When you are doing data science, you want to be able to create various types of plots and tell a story across your data. So storytelling is important when we're talking about going from data to information and ultimately to knowledge. Your data tells a story, and visualizations help you visualize that story. And these visualization libraries help you do it in Python. Machine learning also falls under data science. The machine learning library for Python is scikit-learn. And with scikit-learn, we can do supervised learning, like regression and classification, unsupervised learning techniques like clustering and dimensionality reduction, and evaluating models and tuning them for performance. If we look at scikit-learn, in the documentation, again, there's a user guide and an API and examples. Classification is one of the machine learning tasks, and you can find a lot of classification algorithms under this link. Regression is another task, clustering is another task, and there are many algorithms provided by scikit-learn for those as well. Reducing dimensionality in your data set, selecting a model, and pre-processing your data, doing things like feature extraction. And again, the documentation here is very nice and provides some examples for different types of classification, clustering methods, and so on in scikit-learn. So if you're doing machine learning at all in Python, you are going to be using scikit-learn. And for data science, you do need an understanding of statistical concepts. So we mentioned statistics and math are a component of data science. So you do need some understanding of stats, things like probability distributions, hypothesis testing, statistical inference. I put a link here to the Python statistics module. And this just gives us some high-level statistics like mean, median, mode, standard deviation, variance. There are, of course, other more advanced statistical libraries that you can pull in to Python to use. And then we briefly touched on data cleaning and pre-processing, doing things like handling missing values, detecting outliers, and treating those, and engineering features. So scikit-learn gave us some of the techniques there, but in general, you'll use Python core language to do a lot of things for pre-processing your data and getting it ready for analysis. So this is a big picture of all of the technologies and techniques and libraries available in Python that make Python so powerful for data science and machine learning activities. Stay tuned for continued lectures where we'll go through the fundamentals of Python in more detail and continue through tutorials on all of the different libraries and provide examples for use.